Trigonometry, double angle and half angle formulas. What are they? Trigonometry deals with relations between sine lengths and angles of triangles and more. Why? Helps architects to calculate structural load, roof slopes, and other aspects. Interesting fact, about once a year, a female seal, called a cow, gives birth to a pup on land. Now, let's take a look at the double angle formulas of sine, cosine, and tangent. Here, the key bit of information is that cosine has 3 different formulas. Now, which one is the best? Well, that depends on the information given and which one is easier for you to memorize. Next, let's take a look at the half-angle identities and half-angle formulas of sine, cosine, and tangent. Here, we have 2 key bits of information. The first is that we have a plus or minus in front of the square root. Depending on which quadrant the angle is, we will have a positive or negative square root. Second, we have tangent has 2 formulas. Once again, which one is the best? Well, that depends on the information given and which one is easier for you to memorize. Now, let's take a look at the examples we're going to discuss in today's video. Let's take a closer look at example 1. Now, let's read the steps. Step 1, write down the formula's identities. Step 2, use a unit circle. Step 3, draw a coordinate grid. Step 4, substitute the angle into the formula. Step 5, follow order of operations. Now, let's read the question. Find the exact values of sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. For cotangent of theta is equal to 4 over 3, where the angle has to be between 180 degrees and 270 degrees. Let's insert our graph, because it will make our life easier. The second thing we're going to do is change cotangent to tangent. What do we think tangent is equal to? That's correct, 3 over 4, because tangent is the reciprocal of cotangent. Now, we've changed cotangent to tangent because we're more familiar with tangent, and tangent is better looking. Now, let's refer back to the question. We need our theta to be between 180 degrees and 270 degrees. Which quadrant do we think our theta will be? That's correct, quadrant 3. The next question is, how do we know where to put the point? Remember, tangent is the y part of the ordered pair over the x part of the ordered pair. So we need to go 4 to the left and 3 down. Luckily for us, this has a special triangle, the 3, 4, 5 right triangle. If we remember this, we can find the missing sine length a bit faster. Otherwise, we can always use the Pythagorean theorem. Either way, the hypotenuse is 5. Now, we can find sine of theta. What do we think is sine of theta? That's correct. Sine of theta is equal to negative 3 over 5. Ooh, wait a second. Why is it negative 3 over 5 and not 3 over 5? That is correct. Although the distances of our triangle are positive, we're still at the point negative 4, negative 3. And sine deals with the y part of the ordered pair. So that is why we have a negative. Last but not least, let's find cosine of theta. What do we think is cosine of theta? That's correct. Cosine of theta is equal to negative 4 over 5. Ooh, wait a second. Why is it negative 4 over 5 and not 4 over 5? That is correct. Although the distances of our triangle are positive, we're still at the point negative 4, negative 3. And cosine deals with the x part of the ordered pair. So that is why we have a negative. Now, we have to find the double angle of tangent, sine, and cosine. Let's start with tangent. And tangent of 2u is equal to 2 times tangent of u over 1 minus tangent squared of u. So let's substitute 3 over 4 for each tangent. So now we have 2 times 3 over 4 over 1 minus 3 over 4 squared. Let's multiply our numbers. 2 times 3 over 4 is 6 over 4, which reduces to 3 over 2. And 3 over 4 squared is 9 over 16. And 1 minus 9 over 16 is 7 over 16. So now we have 3 over 2 over 7 over 16. Since we're dividing a fraction by a fraction, let's flip the second fraction so we can multiply. And 3 over 2 times 16 over 7 is 48 over 14, which reduces to 24 over 7. So tangent of 2u is equal to 24 over 7. Next, we have to find sine. And sine of 2u is equal to 2 times sine of u times cosine of u. So let's substitute negative 3 over 5 for sine of u and negative 4 over 5 for cosine of u. So now we have 2 times negative 3 over 5 times negative 4 over 5. Let's multiply those fractions. And negative 3 over 5 times negative 4 over 5 is 12 over 25. And 2 times 12 over 25 is 24 over 25. So sine of 2u is equal to 24 over 25. And last but not least, cosine. And cosine of 2u is equal to cosine squared of u minus sine squared of u. Now, we can use any of the three formulas, but we decided to use cosine squared of u minus sine squared of u. You can check the other formulas to see if the result is the same. Put it in the comments if you like. Now, let's substitute negative 4 over 5 for each cosine and negative 3 over 5 for each sine. So now we have negative 4 over 5 squared minus negative 3 over 5 squared. Let's square each fraction. So negative 4 over 5 squared is 16 over 25, and negative 3 over 5 squared is 9 over 25. So now we have 16 over 25 minus 9 over 25, and the result of that is 7 over 25. So cosine of 2u is 7 over 25. And that is example 1. Let's move on to example 2. Whoa, the steps have changed. Let's read them. Step 1, write down the formulas or identities. Step 2, use the unit circle. Step 3, double the angle. Step 4, substitute the angle into the formula. Step 5, follow order of operations. Now, let's read the question. Use half-angle formulas to find the exact value of cosine of 157 degrees in 30 minutes and tangent of pi over 8. Now, let's write down the half-angle formula for cosine. So cosine of u over 2 is equal to plus or minus the square root of 1 plus cosine of u over 2. 157 degrees and 30 minutes is a nasty number because it is not on the unit circle. So let's set cosine of 157 degrees and 30 minutes equal to cosine of u over 2 so we can find a number on the unit circle. Since each side has cosine, we can set 157 degrees and 30 minutes equal to u over 2. Now, we can multiply each side by 2, so u is equal to 315 degrees. So cosine of 157 degrees and 30 minutes is equal to cosine of 315 degrees over 2. Now that we know what u is, let's substitute 315 degrees for each u. So now we have the negative of the square root of 1 plus cosine of 315 degrees over 2. Whoa, whoa, whoa! Why do we think we only have a negative in front of the square root? That's correct. We are in quadrant 2, so the x part of the ordered pair is negative. That's why we have a negative in front of the square root instead of a positive. Using the unit circle, cosine of 315 degrees is square root of 2 over 2. Remember, cosine is the x part of the ordered pair. Let's combine the numbers 1 and square root of 2 over 2 to make one term. How do we think we do that? That's correct. We rearrange 1 as 2 over 2 so we can match the denominator of square root of 2 over 2. Now, we can combine the numbers. So we have the negative of the square root of 2 plus square root of 2 over 2 over 2. Now, we have a fraction divided by a number. Let's flip the bottom number to 1 over 2 so we can multiply. And 2 times 2 is 4. So now we have the negative of the square root of 2 plus the square root of 2 over 4. We still have one more step. Do we know what it is? That's correct. We can split the fraction in half by putting a square root on the top and bottom part, and the square root of 4 is 2. So now we have the negative of the square root of 2 plus the square root of 2 over 2. That is example 2a. Let's move on to example 2b. Let's write down the half-angle formula for tangent. So tangent of u over 2 is equal to 1 minus cosine of u over sine of u. Now, we could also use sine of u over 1 plus cosine of u, but we will leave that for you to check to see if that formula gives the same result. Put it in the comments if you like. Pi over 8 is a nasty number because it is not on the unit circle. So let's set tangent of pi over 8 equal to tangent of u over 2, so we can find a number on the unit circle. Each side has tangent. We can set pi over 8 equal to u over 2. Let's cross multiply. So now we have 2 pi is equal to 8u. Let's divide both sides by 8. So u is equal to 2 pi over 8, which reduces to pi over 4. So tangent of pi over 8 is equal to tangent of pi over 4 over 2. Now that we know what u is, let's substitute pi over 4 for each u. So now we have tangent of u over 2 is equal to 1 minus cosine of pi over 4 over sine of pi over 4. Using the unit circle, cosine of pi over 4 is square root of 2 over 2, and sine of pi over 4 is square root of 2 over 2 as well. Remember, cosine is the x part of the ordered pair, and sine is the y part of the ordered pair. This time, instead of rearranging the 1 as 2 over 2, so we can combine the fraction on top to make one term, we're going to multiply the top fraction and bottom fraction by 2, so we can get rid of the denominators. And the result is 2 minus the square root of 2 over the square root of 2, because 1 times 2 is 2, and the 2 under each square root of 2 cancels with the 2. Now, we need to rationalize the denominator. So let's multiply the numerator and denominator by the square root of 2. And the result is 2 times the square root of 2 minus 2 over 2. Let's separate our one fraction into two fractions so we can simplify even further. And since each have 2 over 2, we can simplify to the square root of 2 minus 1. That is example 2b. Now, it is your turn. So go ahead and pause the video here so you can take your time to answer this question, and I'll show you the results in 3, 2, and 1. Here's the coordinate grid to find tangent, sine, and cosine. Here's the half angle for tangent and cosine, and here's the half angle for sine. Did you get it correct? Fantastic. If not, there's always tomorrow.